We all grew up memorizing that there were 9 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Then suddenly, it was declared that Pluto was not a planet. Many of us accepted that. Some of us still argue that Pluto has been treated unfairly. So, what exactly happened that Pluto was demoted from planet status? For example, why is Mercury considered a planet while Pluto is not? What exactly determines what is and isn't a planet? And could there be a 9th planet beyond Pluto? Let's take a look. When we think of the solar system, we usually picture the sun at the center with planets orbiting around it. But in reality, our system is not made up solely of our star and the planets. For instance, there is a region called the asteroid belt between Mars and Jupiter. This belt is located about 3.54 astronomical units away from Earth, roughly 3.54 times the distance between the Sun and the Earth. The celestial rocks in this belt, which orbit the Sun, are too small to be considered planets. They are merely chunks of rock. Yet among them, there are giant bodies like Ceres, which, although 14 times smaller in mass than Pluto, manages to contain about 25% of the total mass of the asteroid belt. Beyond Neptune, there is another belt of asteroids known as the Kuiper Belt. But this belt differs from the one between Mars and Jupiter. Most of the objects here contain frozen water. In other words, ice. When one of these objects, through collision with a nearby body or due to the gravitational influence of a planet, deviates from its path toward the sun, the ice begins to melt, and a tail made of dust and water vapor forms, which we call a comet. Even farther out than the Kuiper Belt lies the Oort cloud, a vast and mysterious region containing countless celestial objects of various sizes, though we know very little about it. But that is a topic for another video. Now, among the objects in the Kuiper Belt, undoubtedly the most interesting is Pluto. So, what is it about Pluto, or what does it lack, that warranted such an extreme decision as removing its planet status? Let's try to determine that. At first glance, Pluto doesn't seem odd. It has a spherical geometry like the other planets and orbits the sun just like they do. Its surface and composition do not appear drastically unusual. In other words, while other planets move along elliptical orbits, there's nothing as if Pluto were drawing triangles in its orbit. But to understand Pluto's oddities, we need to examine its characteristics in more detail. Take its orbit, for example. While all the planets orbit in nearly circular elliptical paths, Pluto's orbital eccentricity, that is, the deviation of its orbit from being a perfect circle, is around 0.25. If the eccentricity were 0, you would have a perfect circle. The closer the value is to 0, the more circular the orbit is. For example, Earth's orbital eccentricity is only about 0.02, nearly a perfect circle. Venus's is about 0.007, almost a perfect circle. For Pluto, however, the difference between its closest and farthest distances from the Sun is nearly 3 billion kilometers, whereas for Earth that difference is only about 5 million kilometers. Due to this absurd difference, the amount of sunlight and temperature on Pluto's surface change dramatically. But that alone is not enough to disqualify it as a planet. For instance, Mercury's orbital eccentricity is also quite high, around 0.2, similar to Pluto's. Another oddity of Pluto is its orbital inclination. While all the planets orbit roughly within the same plane, Pluto's orbital tilt is about 17.2 degrees, meaning it significantly cuts across the common plane in which the other planets orbit. Yet, note that other planets also have unusual rotations. When viewed from above their north pole, all the planets rotate counterclockwise, except Venus, which rotates clockwise, and Uranus, whose axis is tilted by about 98 degrees. Thus, orbital tilt alone does not disqualify Pluto. Yet another anomaly is Pluto's distance from the Sun. Pluto orbits so far from the Sun that one Pluto year is equivalent to 248 Earth years. Since its discovery in 1930, Pluto has not yet completed a single full orbit around the Sun. In fact, by the time it returns to its discovery point, it will be the year 2178 on Earth. But we cannot dismiss Pluto as a planet solely because of that, or consider its size. At the time of its discovery in 1930, Pluto was thought to be about the size of Earth. But subsequent observations gradually reduced its estimated size. In 1948, Gerard Kuiper, yes, Kuiper, showed that Pluto could be at most the size of Mars. Then, in 1976, Dale Cruikshank and two colleagues argued that Pluto's seemingly large size was due to its highly reflective surface. It appeared much larger than it really was, and estimated that its mass would be only about 1% of Earth's if this were taken into account. Finally, more careful observations revealed that Pluto is not alone. It has a satellite about half its size. Thus, Charon was discovered, which allowed for a more accurate calculation of Pluto's size. It turned out that Pluto is about 500 times smaller than Earth, with a diameter of only about 2,400 kilometers. That is, not only is it far from being as large as Earth, it's even smaller than our moon. In fact, Pluto's surface area is even smaller than that of Russia. But being small by itself isn't necessarily a problem. After all, Mercury is also a very small planet, yet it is still a planet. The most significant anomaly of Pluto, however, is its location in the solar system. While all the other planets lie between the Sun and, as mentioned earlier, the Kuiper Belt, Pluto is located directly within the Kuiper Belt. In fact, it is more accurate to say that Pluto is not only within the Kuiper Belt, but also was the first object we discovered in that region. Until Pluto was found, we had no inkling that such a belt even existed. This is a very strange situation. In fact, the first Kuiper Belt object other than Pluto was not discovered until August 30, 1992, by David Jewett and Jane Liu, 62 years after Pluto's discovery. In 1951, the Dutch astronomer Gerard Kuiper, who first predicted the existence of a belt beyond Pluto, had his name given to that region. Since 1992, more than 2,000 objects have been discovered in the Kuiper Belt. What ultimately undercut Pluto's status was the discovery that several of these Kuiper Belt objects are nearly as large as Pluto. With each new discovery in that region, Pluto's status as a planet became increasingly threatened. The final blow to Pluto's planetary status came in 2005 from American astronomer Michael Brown and his colleagues. While processing data collected in 2003 from the Palomar Observatory, they discovered an object initially designated 2003 UB313, later named Eris. At first, Eris was thought to be even larger than Pluto, but it was later determined to have a diameter of 2,326 kilometers, just slightly smaller than Pluto's 2,377 kilometers. Regardless, the existence of objects in the Kuiper Belt that are comparable in size to Pluto was firmly established. In the same year, a team led by José Luis Ortiz Moreno at the Sierra Nevada Observatory discovered Haumea, a 2022-color object in the Kuiper Belt, independently detected also by Michael Brown's team. That same year, Michael Brown discovered yet another object, Makemake, with a diameter of 1,434 kilometers. These astronomical hat tricks by Michael Brown and his colleagues created a stir in the astronomical community. Should all of these objects be called planets? If so, how many planets would there be in the solar system? 25? 40? 50? At that point, the International Astronomical Union, IAU, reached a peculiar awareness. Until then, no one had formally defined what a planet was. The term planet is so ancient. The word planet, from the Greek planets, meaning wanderer, was used since ancient Greece to describe those celestial bodies that moved noticeably faster than the other stars. The world we live on was clearly considered a planet. Over the centuries, great figures such as Pythagoras, Plato, Aristotle, Ptolemy, and Copernicus shaped the definition of a planet, and eventually the term asteris planetae, wandering stars, became established. So when the IAU was founded in 1919, there wasn't even a felt need to define something so obvious. But clearly, the cards in the solar system were being reshuffled. An official definition of planet was needed. In August 2006, at a meeting in Prague, IAU members decided to establish an official definition of a planet. Thus, the definition we use today was created. According to this definition, for a celestial body to be considered a planet, it must orbit the Sun. Now, let me ask you, in the entire universe, how many bodies do you think orbit the Sun? 8? Yes, 8. And that number will likely never change because we will never discover another object orbiting the Sun. Of course, that doesn't mean that other stars don't have round bodies similar to ours. They do exist, but we refer to them as exoplanets, not simply planets. Meanwhile, Pluto meets the first criterion since it orbits the Sun. 2. It must have sufficient self-gravity to overcome rigid body forces so that it assumes a nearly round shape, hydrostatic equilibrium. This is a more technical criterion, but it essentially means that a celestial body must not be irregularly shaped. It must be nearly spherical. This criterion excludes many rocky bodies like asteroids, but it does not exclude Pluto because Pluto is nearly spherical. 3. Finally, the body must have cleared its orbit of other debris. That is, it must have cleared the neighborhood around its orbit of other objects. Objects that still share their orbits with many other bodies, such as those in an asteroid belt, cannot be considered planets. This is the criterion that killed Pluto as a planet. Because Pluto, being a Kuiper Belt object, has not cleared its orbit, it is embedded in a region full of other objects. And this is not only true for Pluto, but also for other Kuiper Belt objects like Eris or Makemake. For this reason, we can no longer call Pluto a planet. So, what do we call it? The IAU developed a new category for such objects. If a celestial body meets the first two criteria but not the third, then we consider a fourth question. Is the body a satellite of a larger body? If yes, it is officially classified as a natural satellite. If not, then it is designated as a dwarf planet. Pluto meets these criteria and is therefore categorized as a dwarf planet. In fact, all those other objects that displaced Pluto from its throne are also classified as dwarf planets. In popular culture, this reclassification is often treated half-jokingly. Think, for example, of Cem Yılmaz's jokes about Pluto, or the countless mugs and t-shirt designs that proclaim Pluto will always remain a planet in our hearts. Occasionally, you even see news headlines suggesting that Pluto is a planet again. These are usually the result of April Fool's Day pranks or exaggerations stemming from a prominent figure, like a former NASA chief, jokingly suggesting that Pluto should be a planet. These things, of course, help increase public interest in science. But no, Pluto is not a planet and will never regain its planet status. Why? Because Neptune's immense gravitational pull creates what is known as an orbital resonance with Pluto. This resonance locks the orbital periods of Neptune and Pluto relative to the Sun. For every 3 orbits of Neptune around the Sun, Pluto completes 2 orbits. This stabilized motion greatly reduces the chance that Pluto will be scattered by Neptune, and when combined with Pluto's very small mass and the sluggish movement of objects in the Kuiper Belt, Pluto's ability to clear its orbit becomes practically zero, even over hundreds of millions of years. And that is a very good thing. Because although our sympathies might incline us to pity Pluto, placing it in the underdog category, the discovery of the Kuiper Belt, to which Pluto belongs, whispers very important secrets about ourselves. Ask yourself, why does the Kuiper Belt exist? Why did a planet not form there to accumulate all the Kuiper Belt objects? Because when the solar system was forming, the mass that made up the system was spread out like a disk. In other words, the Kuiper Belt, like the interior of the solar system, is made up of countless bits of dust and rock. Some of these clumped together at certain points to form what we call planetesimals, the building blocks of planets. Some of these planetesimals then accreted surrounding material and became protoplanets, and some of these protoplanets cleared their orbits to become the planets we know today. But in regions at a certain distance from the Sun, clumping was insufficient. The asteroid belt is one such region. The Kuiper Belt is another. In the asteroid belt, the giant mass of Jupiter prevented sufficient accumulation of material. In the Kuiper Belt, the culprit was, as mentioned, Neptune's massive gravity. In both regions, the density of material was too low, spread over a vast volume, for large cores to form. A series of such factors prevented a planet from forming there, and that is a wonderful thing from an astronomical perspective, because the asteroid belt between Mars and Jupiter is a region heavily influenced by the Sun and the neighboring planets. The rocks there have undergone billions of years of change under the Sun's scorching heat. But the Kuiper Belt, being so far from the Sun and the other planets, still retains properties that closely resemble the solar system's original state from 4.6 billion years ago. Thus, by studying and comparing the asteroid belt and the Kuiper Belt, scientists can understand how proximity to the Sun affects planets, their surfaces, and their interiors. This is extremely valuable for understanding the dynamics of stellar systems. In short, the Kuiper Belt offers us a laboratory of system-scale phenomena. Yet, with our current technology, reaching the Kuiper Belt is extremely difficult. So far, the only spacecraft we have sent that has provided us with clear images of Pluto is New Horizons. Voyager 1 and 2 also passed through the Kuiper Belt, but at that time, the belt was largely unknown, so they did not send back meaningful data. Even this simple fact tells us something very important. In the asteroid belt, the average distance between any two randomly chosen objects is about 1 million kilometers. 1 million. Imagine trying to navigate a 20 to 30 meter spacecraft in such vast distances, or even spotting two asteroids simultaneously. It's practically impossible. Now consider that in the Kuiper Belt, the average distance is not merely 1 million, but millions of kilometers. Space is truly immense. So, you see, it is not that Pluto isn't a planet, it's that Pluto simply could never be one, and that fact teaches us many valuable lessons. Like all truths in the universe, we must learn to accept Pluto as it is rather than as we wish it to be. Only then can we reach the truth. Pluto is not a planet, and it never will be a planet. In the next video, we will continue our journey. Goodbye.